Alright, in 4.2a, we're going to look at observational studies and experiments. So let's look at this study. A mother smoking during pregnancy and exposure to lead significantly increases her child's risk for developing attention deficit hyperactivity disorder, say researchers. In fact, as many as 1/3 of cases of ADHD in children are linked to exposure to tobacco smoke and lead before birth, giving moms yet another reason to quit smoking during pregnancy. For the study, researchers from Cincinnati Children's Hospital Medical Center surveyed over 4,700 children between ages of 4 and 15 and their parents. Over 4% of the children included had ADHD. The researchers found that those children whose mother smoked during pregnancy were over twice as likely to develop ADHD than a child whose mother had not smoked. So, based on this study, should we conclude that smoking during pregnancy causes an increase in the likelihood that a child develops ADHD, and explain? Well, you can't make this conclusion, okay? ADHD could be because of other factors besides smoking. And the study is really just an observational study. They didn't have any treatments in there. So you can't have a conclusion that says this causes that if it's just an observational study. But the most evident thing is that ADHD may be caused by other things besides smoking. So confounding, or sometimes called lurking variables, occur when two variables are associated in such a way that their effects on a response variable cannot be distinguished from each other. So those are variables that you really can't separate out. Okay? Possible confounding variables in the context of this study. Well, what other things could cause ADHD? Well, genetics, environmental factors, other factors during pregnancy, like what the mom ate, did she drink, all kinds of other things could contribute to a ADHD child. There's a lot of things that overlap, and so you can't completely separate them out, so we would call those confounding or lurking variables. Now, is there a way to prove that smoking causes ADHD? Well, the only way to prove a causation is through a true experiment. But if I assign some pregnant women to smoke and others not to, that would be considered unethical. You just can't do that. That would be wrong. Okay? So in this situation, it is not feasible to prove that smoking causes ADHD, because you're not going to tell a pregnant woman to smoke. That doesn't work. All right? So we'll talk more about what is an experiment and stuff in a moment. So an observational study observes individuals and measures variables of interest, but does not attempt to influence the response. An experiment deliberately imposes some treatment on the individuals to measure their responses. Those are the key differences. Observational study, you're just observing people and writing down what happens, making observations. Experiment is you impose some kind of treatment. All right, so what are differences? Well, an observational study only observes. An experiment imposes a treatment. Okay, in this case, smoking. Okay, this one, what we just saw, only observed. Mothers, whether they smoked or not, didn't tell them to do that. They just did it anyway. Another thing, you can only describe and compare groups and look at a correlation. But correlation does not mean cause. But if you did an experiment, it is possible to determine if an explanatory variable causes a change in the response. That only works under an experiment, though, not observational study. Confounding variables are issues here with observational study. But with an experiment, confounding variables are not an issue for well-designed experiments, because those confounding variables get evenly distributed in the treatment groups, and we'll discuss more of that in a moment. But if you don't have treatment groups like in an observational study, those variables are a problem. All right, so let's look at this example. Family dinners versus good grades. Does eating dinner with their families improve students' academic performance? According to an ABC's news articles, teenagers who eat with their families at least 5 minutes a week are more likely to get better grades in school. This finding was based on a sample survey conducted by researchers at Columbia University. So part A, was this an observational study or an experiment? And we justify it. Well, it says that teenagers this is based on an observational study because they didn't impose the treatments. They didn't tell which teenagers to eat dinner with their families and which ones not to. They just watched and took notes. What are the explanatory and response variables? Well, the explanatory is the number of times that the teen eats dinner with their family in a week. That's what they're looking at. And what they say the response is that the teen's grades will be better. Okay? So explanatory is what do they think in some ways causes it, and the response is what's the outcome. So C says, explain why such a study cannot establish a cause and effect relationship. Suggest a variable that may be confounding with whether families eat dinner together. Well, can't establish causation because an experiment was not conducted. This was an observational study. Students' grades could be affected by the amount of studying they do, or if they have a job, or fill in the blank. There's all other kinds of reasons that could affect their grades besides just the number of times they eat dinner with their family. All right, so there's some important vocabulary you need to know that deals with experiments only, all right? So these 4 vocabularies are real important. In experimental units, it's the smallest collection of individuals to which treatments are applied. When the units are human beings, we call them subjects. Okay, it could be animals, it could be dishwashers, it could be anything, but it's the smallest collection of individuals. And like it says, if it's humans, we call them subjects. Now, treatment is a specific condition applied to the individuals in an experiment, like drinking a soda or taking a medication or placebo, whatever. A factor is the explanatory variable or variables in the experiment. Okay, there may be more than one thing that we're treating people with, and those are called factors. If the factors have further levels, further options on them, we call them levels. Okay, in an experiment, that studied the joint effects of several factors, each treatment is formed by combining a specific value, often called a level, to each of the factors. So I'm going to demonstrate this for you. Okay, if I have a factor and there's multiple levels, what it's going to do is generate more treatments that are applied. And we're going to go through an example and I'll show you what I mean by that. But you need to be able to differentiate between the 3 of those. So let's look at this example. So what are the effects of repeated exposure to an advertising message? The answer may depend on both the length of the ad and how often it is repeated. An experiment investigated the question using 120 undergrad students who volunteered to participate. All subjects viewed a 40-minute television show that included ads for a digital camera. Some subjects saw a 30-second commercial, others saw a 90-second version. The same commercial was shown either 1, 3, or 5 times during the program. After the viewing, all the subjects answered the question about their recall of the ad, their attitude toward the camera, and their intention to purchase it. So let's differentiate some of this vocabulary. So who are the subjects in this experiment? It's the 120 undergrad students mentioned. Now the factors, what are the things we're looking at here? Well, there's 2 in this one actually. The length of the ad, which is 30 seconds or 90 seconds, so it has 2 levels, and that one factor. The second factor is the frequency of the ads, with 3 factors. Did they see that ad 1 time, 3 times, or 5 times? So this has 2 factors, but it has 2 levels here, 3 levels with frequency of ad. Now, what's the response variable in this question? It's the recall their attitude and their intention to purchase it in their answers. Okay. So then the treatments. This is where all the factors and levels come in. This one actually has 6 treatments because we have 2 times, 2 different lengths of the commercial, and frequency. So when I combine those, that's going to create 6 different treatments. I've got one that's 30 second and they only saw it once. One 30 second, they saw it 3 times, 5 times. And then with 90 seconds, there's a group that saw it once, twice, or once, 3 times, and then 5 times. So all in all, that means that there were 6 different treatment groups in this experiment. And it goes back to, again, how many factors and how many levels of each factor. We'll do an example or two of this in your homework, so make sure you pay attention to those.